In this video, we're going to look at estimating a definite integral. We will look at two examples. First, let's look at the theory. And recall if there's a function f of x that's less than or equal to capital M is the absolute maximum of the function on the interval, closed interval a to b, and it's larger or equal to small m, that's the absolute minimum of the function on the closed interval ab. Then the definite integral a to b f of x dx, which is essentially the area under the graph of the function f of x from a to b. This definite integral, the value of this definite integral is less than or equal to the area of the larger rectangle given by capital M times b minus a, and it's larger or equal to small m times b minus a. So we're going to apply this property to estimate the integral from 1 to 8 third root of x dx. The first thing we should do is look at the graph of this function. So what we have is y is equal to x to 1/3. That's going to look something like this. When x equals 1, the y value is 1 by plugging 1 into the function. Third root of 1 is 1. And plug in 8 into the function. That's 8, 2. And so clearly you can see that the absolute maximum is going to be 2. That's the y value, the highest y value, which is this 2. And the absolute minimum is going to be 1. All right, let's label this properly. This is x-axis, this is y-axis, and this is the origin, and the curve is y is equal to x to 1/3. All right, so what we have is x to the 1/3 is between 2 and 1. For x, between 8 and 1. Now let's apply the property. Definite integral from 1 to 8, x to 1/3 dx, is less than or equal to 2 times 8 minus 1. This is capital M times b minus a. And it's larger or equal to 1 times 8 minus 1. This is small m times b minus a. So the integral 1 to 8 x to 1/3 dx can be estimated to be between 2 times 7, that's 14, and larger or equal to 1 times 7, that's 7. So this is the estimation for this definite integral. It's between 7 and 14. All right, let's look at another example. So here we have estimating the integral from 0 to 1, 2 to the minus x squared dx. The first thing we notice is that this is a negative exponential. It is decreasing. So we have to, let's actually do a graph of this and show that it's decreasing. So here we have, when x is 0, the y value is 1. And when x is when x is equal to 1, the y value is going to be 2 to the minus 1, which is 1/2. Let's shade this region in green. So clearly, we can see that this is capital M, or this is small m, which is 1/2, the absolute minimum. And this is capital M. Capital M is going to be 1. So this is x-axis, y-axis, and y is equal to 2 to the minus x squared. All right, so now let's show some of the computations. X, y is equal to 2 to the minus x squared. When x is 0, y is 2 to the minus 0 is equal to 1. This is going to be the absolute maximum. And when x is 1, y is equal to 2 to the minus 1, that's equal to 1/2. This is the absolute minimum. All right, so m, small m, is f of 1 is equal to 1/2. That's the absolute min. And capital M equals f of 0 equals 1. That's the absolute max. All right, so what we have is the function 2 to the minus x squared is between 1 and 1/2. For x, between 1 and 0. Now the integral from 0 to 1, the definite integral, 0 to 1, 2 to the minus x squared dx, is less than or equal to 1 times 1 minus 0. This is capital M times b minus a. And larger or equal to 1/2 times 1 minus 0. And this is going to be small m times b minus a. So we now have a bound for this integral, 0 to 1. We can estimate the value of this definite integral is less than or equal to 1, larger or equal to 1/2. Now, you may ask, can this integral from 0 to 1, 2 to the minus x squared dx, can this integral be evaluated exactly? Well, the answer is no. We can't compute this exactly. But if you give this to Wolfram Alpha and give it to computer software to give a very accurate estimation for the value of this definite integral, this comes out to approximately 0.810025. And you will see that it's actually between the upper bound and the lower bound that we found earlier. So it's, the 0.81 is less than 1 and larger or equal to 1/2. So this is an example of estimating a definite integral. All right, thanks.